Electrostatics, lesson 19, electric potential 2. Yesterday we did electric potential 1. Okay. In that, first we have seen how electric potential energy for a conservative force is defined. The differential form and the integral form. Okay. And we told this is valid for these three forces: gravitational force, electric force, and spring force. But this electric force is formed by charges, not by what? Not by, tell me, not by dB by dt. I told yesterday. This dB by dt also forms electric fields. Huh? Hello, can you hear me? All right. So both the differential form and integral form are valid for all the three kinds of forces. But currently we will be talking about electric potential energy. Okay. This one. So both the definitions you are okay with. A minus sign will come if I put electric force. Minus sign will go, and this comes when you move it with a constant speed against the electric force. All right. Then
Yes.
we wrote both the things in the mathematical form, in the integral form, and then we applied it for a particular case of Q1, Q2, and got that potential energy is K Q1, Q2 by R. So little summary here. Little summary you put here. Look, plus Q1. And the formulas I'm not writing again. I'm just writing formula. I mean the basic definition I'm not writing again, but the formulas I'll write. U in this system will be what? 1 by 4 pi epsilon 0 plus Q1 plus Q2. Carry the signs all the time by R.
Yes.
The first. 2 plus Q1 minus Q2. The distance R, what should I write for you?
1 by 4 pi epsilon plus Q1 minus Q2
minus Q2 by R. Third case, minus Q1 minus Q2. Distance R. So what will I get for you here?
1 by 4 pi epsilon 0 minus Q1 minus Q2
by R. So this is what we have for the formulas, or the summary in terms of the formula. Okay. So for a system of charges, we can finish it here itself. For a system of charges, system of point charges, U will be what? System will be, what should I say here? Hello.
Sum of the all.
Sum of what?
All the potential energies.
All the potential energies. What do you mean by that?
Like if one charge is already there, when we're bringing the.
So instead of writing in a algebraic way, we'll mention it in words here. That is, U of the system will be equal to what? Potential energy for all pairs of charges. Sum of potential energy of all pairs of charges there, or every pair of charge. Okay. So for every pair you find out and add. That will give you the potential energy of the whole system. Right?
Yes, sir.
So immediately one can go for an example here. Like I have plus Q1 minus Q2 plus Q3, the vertices of the triangle, equilateral triangle of side A. So U equals how much?
So it
U
will
equals,
be for 1, 2, 2, 3, and 1, 3.
yeah, you will write it as what? U equals, K you can write, brackets, plus Q1 minus Q2 by A. So minus Q1 Q2 by A plus Q1 plus Q3 by A plus minus Q2 plus Q3 by A. So minus Q2 Q3 by A. So this will be simply the potential energy of system of charges. Is it okay?
Yes.
But as we told, this potential energy is not enough. We'll go for potential, electric potential. If I finished it, I'll continue. Tell me. Can I continue?
Yes.
Now, so until now, this was not very, not many formulas have been added yet. The basic definition, and then from that, how to find out the potential energy of a system of two charges, and then how to extend it for many charges. All right. So can you think of the potential energy of a single charge Q? Tell me.
Meaning only for one charge? No, sir.
You cannot. Remember, any time, whenever you define a potential energy, you're actually defining it for a system of charges. Though many a time we somewhat misunderstand it. I'll tell you. When you said Earth is here, from the ground, if a body is at a height h, from a height h, at a height h, if I have a body of mass m, we say it is a potential energy mgh is of this basically. Do you follow? But you remember that couldn't have been defined if Earth were not there, first of all. Do you follow?
Yes, sir.
Because the work done to move this charge against the gravity only became potential energy. So under the action of an attractive or repulsive force, only you will define potential energy, even for a particle, even if you say it is for a particle, right? But remember that forces wouldn't have been there if there was no other particle in the body there. So do you follow my point? But why this kind of a statement we make, we generally think Earth is at rest, only this moves. So we don't say potential energy system of this and this, but we'll say potential energy of only this, because as it is moving, the decrease in potential energy will convert into kinetic only for this. And we think this is not moving. But in fact, whatever it is, potential energy is always for the system of charges. In the sense, work has to be done against their attractive or repulsive force. That work only will be called potential energy. All right. So I should continue now. Okay. Therefore, after that, electric potential, of course.
Sir,
Tell me.
So if a second particle is not there, there won't be a force of
force. So there's no potential energy definition. Try to understand.
yes. Yes.
There should be a force, and that force should be a central force. I told you already. That should be a conservative
Yes.
force, let me say, at least directly. Only then it will potential energy will be defined. Electric potential. Now look at this. In an electric field, PD between 2 points. PD between 2 points is defined by the relation what? V2 minus V1 equals minus W122 by Q naught. Do you follow? Or
Yes.
W12 by whom?
Electric force.
Yeah. Or V2 minus V1 equals W122 by Q naught by
external force with constant speed.
So these are the two definitions of electric potential difference between 2 points in a field. All right. By
Yes.
making potential at a point 0, at a reference point we choose to be 0, by making electric potential 0 at a point, at one of the points. One of the points means either 1 or 2. We define or we get the potential at the other point. Right? So you have to continue.
Done, sir.
Right. Now we'll come back to this again. See, V2 minus V1 equals W122 by Q naught we wrote, isn't it? By external force. This I'll focus more for meaning. See, what do you mean by this? W122 by Q naught means what? This is the work done for one work done for 1 coulomb charge, isn't it? This whole thing. For Q naught, you did a work of W122. For 1, how much? W122 by Q naught, isn't it?
Yes.
What do you say?
Yes.
So if we say V2 equals 0 at R2 equals infinity, and V1 equals VR, R1 equals R, I can write from here 0 minus V at R is equal to what? W R to infinity by
Q naught.
Q naught. Or it will be V at R equals, tell me, minus W
R
to infinity by
Q naught.
R, V at R equals W infinity to R by Q naught. Do you follow?
Yes.
So this is our practical definition. How will you put it now? Electric potential at a point. Electric potential at a point in an electric field is defined as, tell me, the work done by an external force against that much work done by an external force against alone. Okay. If I don't want to add the word constant speed, I can do this. Electric potential at a point in electric field is defined as that much work done by an external force against electric field alone.
Electric.
As that much work done, as that work done by an external force just against what? Electric force. Defined as the work done by an external force just against electric force while bringing it from, tell me,
infinity to a point in the
bringing it from infinity to R.
A point in the
point represented by R. So that is the definition. Yes. Mass is there, English is there. So which one do you follow? You just try to follow that. But if you have to write that as a definition for intermediate exam or board exam, 12th exam, you need to write like this. But as an idea, if you remember it from here, that's more than enough. That's how you'll apply in the problems, right? So even there, the second part I was focusing upon for getting a physical meaning to the whole thing. You bring a charge from infinity and place here, you do some work. That work is potential energy. Divide by that charge, that becomes potential. Do you follow?
Yes, sir.
Like what is the use of doing this, Sriya? Potential energy we already had, isn't it so? Why once again a word called potential? I've been talking about this for
because here we can define.
We can define it.
We can for a unit charge, like how much work is done for the unit.
What is the use of it? What is, I've told you this many times actually. Whenever I talk ideas why people refuse, I'm still worried. When you go to a vegetable market or when you go to a fruit market and ask for apples, what will you ask? What is the rate of apples you ask, or how much money for apples or something like that? Even if you ask how much money for apples, you'll say per dozen, per kg, like that he'll tell you. Isn't it?
Yes, sir, for a specific quantity.
So that will be independent of how much you're going to take, right?
Right. Yes.
So now tell me, why do we define electric potential?
Certain potential energy is for the whole system, and even potential will be for the system, but We can define it for a fixed point.
Why 1 coulomb? Just now I gave given you an idea. When you go and ask for apples, he'll say per dozen 240 rupees, right? So if you take some 12 dozens, it will be 12 into 240. If you take 13 dozens, 13 into 240. If you take 100 dozens, 100 into 240. So how much money you spend for it and how many apples you take will be independent. This will be independent. This will be not connected to the rate of apple, the rate of the price of apples. The price of apples will be all the time that only. So it is the property of whom? It is the property of the seller. Tell me. It is the prerogative of the seller to decide a particular rate. So it doesn't depend upon how much you're going to buy. Now tell me.
So this will be a property of the force.
Probability of the
Force.
what force? Probability of the source charge, source field. So by defining it as a work done per unit positive charge, we make it a property of the field rather than which charge is being brought. Like I told you, the price tag given to different consumer goods in the supermarket is the character of the seller. Isn't it so? Tell me.
Yes, sir. Here it will be
It doesn't depend on how
independent
much customers are going to buy. When he says apple's rate is this particular day or 2 days or 3 days, of course they keep changing for a different reason, but he will decide it, right?
Yes, sir. Here it won't depend on the charge we bring in the field.
But once again, you are talking it as a new concept, which I already talked while talking electric field strength. So we are making it property of the space there. Like if I have a charge Q at distance R, we say potential is KQ by R, for example, after derivation. It means this is the property of the source. When I have a charge like this, there is some field around it. So if you say there's a field around it, physics doesn't agree. You should say how much field is there. How much field is there means there are two things. One is kq by r square to measure the field, which is a vector quantity. Like this, kq by r is the potential, which is a scalar quantity. So this electric field and potential now become the property of the field, which means they become the property of the source causing the field. It doesn't depend on what charge you place and bring it. So really talk about like this previously.
Yes, sir. And gravitational. So.
Then where did that go? Others are silent once again. So potential at a distance R, potential at a point R in an electric field is what? W infinity to R by Q naught by external force. If I want to cut short, I can write external force. I should write against electric field. It may do more work against it might do extra work against some other forces, but however much work you do in bringing the charge to a point R. VR is what? Potential at a point described by R. So you bring 1 coulomb, W infinity to R by Q naught means you bring 1 coulomb charge. So that whatever 1 coulomb charge you bring and do that work will be independent of what? The charge you brought, whereas it depends only on the electric field there, electric field formed by the source. This is the mathematical modeling. So if people are not responding, somehow I feel so disappointed. Or you don't feel this is all required for writing exams or so solving problems. So from here you get this one, W infinity to R will be potential at R into the charge brought. This becomes nothing but U. Total gravity is done. So I should not expect anything from you. Then I can easily teach and finish it. How much like, is English a problem, or is catching the ideas is a problem, or you just because it's online, you saying that online I'm not understanding is completely meaningless. It's a psychological issue for me. I mean, I have no issue with online, offline, practical. Now when people go on complaining about online, I feel so funny. Why? Because what was not ordinary commonplace thing 100 years ago, we are thinking it is very, very common now, isn't it? We got used to it. So many habits of human race has changed. What is true now will become obsolete a little later. So who is grabbing that futuristic things? They actually are the right persons to improve. So tell me, what should I do? This talk, this discussion is all waste for you? Actually, there's one more academic interest for me. I can't blame everybody here that they're not listening. They may be listening, but what are they looking at? What are they looking for? Vaishnavi, M, let us understand each other. Because how many times I talked about it already, but now you don't know what am I doing. Like, you just are okay with that formula, Vaishnavi, M?
Yes, sir.
Huh?
Yes, sir.
You're okay with the formula. Huh? But how do you know when to use that formula? You don't care what is W, what is infinity, what is R, what? Like, you remember this, or you think this should be applied somewhere? Vaishnavi? So, okay, which means nothing is going into your head. Let me understand. So what is going into your head, and what are you doing during this 1 hour time every day? No, I tried many times. If I were a student, I mean, like when I was a student, I knew that I was not following, or I knew that I was following, and I know the purpose of that. And I supposing I did not follow something, after 10 years also I remember that sir taught something I never understood. Even that whatever I did not understand, I remembered. So I'm trying to really understand what is bothering the present day generation. I'm trying to understand. I don't even say present day generation, because I am the present day generation, not you. You are old people. You know why? I can take it to any new thing faster than you. Believe me. Any new thing you give me. Only thing is whether I have the physical capacity to do it is a different thing because of age. But I've got enough mental capacity to go ahead of you people. You understand what I mean by that? If I read the instructions of a instruction manual of helicopter, in principle, I'll be able to fly the helicopter with 1 or 2 trials. in principle. Why am I saying in practice? In practice, of course, the reflexes may be not that good, like it will be for young people. But what I was saying is, learning is not an issue at all. So what are you learning with whatever I'm doing like this? Because many times I feel so sorry about myself. Why to talk so much actually? Like a concept, people say some formulas, they write, immediately they go for problems. Even that I can do, no? Or somebody else can do it for you. Vaishnavi Mulukutla. An important idea of electric field and potential I was talking. By defining it per unit thing, we'll be making it independent of whatever charge you bring. You bring 10 coulombs, do a work of 100 newtons. Potential is 100 newtons, sorry, work of 100,000 joules. 1000 joules by 10 coulomb is potential. How much is that? 100 joule per coulomb, which is called 100 volts. So if I bring 20 coulombs, I might do a work of 2000 joules, but potential is once again same thing. But that means whatever charge you bring is of no consequence, because every time you're dividing it by 10 or 20. That means you're not interested in how much work you did for 10 coulombs or 20 coulombs. You are interested in how much work is done for 1 coulomb. But on what factors this will depend? On the source charge. Like if Q is there, the potential is 100 volts here. Probably if 2Q is there, the potential may be 200 volts. So it doesn't depend on what charge you bring there. That charge I called as test charge, if you remember. It all depends on how much the source charge is there. The source is causing the field. So two ideas, two mathematical ideas, electric field and potential are defined, modeled there. Like if I rub this box, this gets charge, extra charge. So it forms a field. So here, I don't see anything with my naked eyes, but I have got E here, I've got V here. That E will be what work must have been, what force must have been experienced by 1 coulomb charge if I place it here. The potential would be what amount of work could have been done in bringing 1 coulomb charge from here to there here. So, but it depends upon how much charge I've got here. It doesn't depend on what charge I bring and place here. Whatever charge I bring, ultimately I require work per 1 coulomb, force per 1 coulomb. So by defining it per 1 coulomb, I'll make it independent of what charge you bring, but make the property, make it property of the source which is causing this field, which is invisible to us. Tell me, Shreya, you tell me. Actually, yes, you are the right person. Did I talk about this previously?
Yes.
Then
in gravitation, we spoke.
No, my point is, I talked there. I'm talking here. Why this talk? Actually, I can just go on giving formulas and doing it. No.
Like
Vaishnavi says she's not worried about the meaning of it. She wants only the formula. But how many formulas are there in physics? So many are there, right? You should know what is the main formula, what are the sub formulas, all that you should know. And how do you apply it for a physical problem there? A physics problem, you need to set it up in the beginning, right? What's happening, who is bringing, what is happening, you should know. Vaishnavi Murukutla, tell me. No, definitely, I'm not angry with you. I just want to know as an educator, what is happening while I was teaching like this, or some Bhaskar teachers, what actually goes on in your minds, you would like to know. You should only tell, because even if I use any equipment, it will only show some brain activity in a particular region, which you're not sure about. Of course, people are even doing that. People measure so many things now by measuring looking at the brain while things are happening. Depending on the area where you see some neural activity in terms of the electrical signals, people tell, are you thinking, are you seeing, are you emoting, are you having better insight than others? People are trying to do that nowadays. All that may be all right, but actual thing is there's no requirement for any instrument like that. If you tell honestly what's happening, learning can happen. Continue. All right. So the unit is what? Unit is volt. How do you define volt? Tell me, how do you define an volt? It's there already. If the work done in bringing a unit positive charge from infinity to a point in the field is 1 joule. Potential at that point is 1 volt. That's the definition of volt. Vamshi.
Yes, sir.
Tell me. Same question I asked Vaishnavi, I'm putting it to you. What will you be looking for in a class? So my issue is this. Now we are today 18th or 19th lessons running. So is that required all this time? Is it worth doing? I was asking.
Yes, sir. It will.
Please. To please me, you're telling?
No, sir. It will work. I'm saying.
Okay, complete the definition. I'll continue. Actually, I'm talking, I'm writing it. Writing like this is not possible. You don't know. It's almost like the regular class. Otherwise, I can bring a presentation, keep talking, go on talking like this, isn't it? That's what you will be facing later when you go to higher studies. They don't bother whether you understood or not. It's assumed that you're all serious-minded people. You're understanding things. It will be assumed like that. People don't look for whether you followed or not. I mean, we're writing. I mean, spontaneously writing it, not some ready-made material I'm showing. That way I can make it more effective. If people are mature, we can make it more effective, more quickly, and then go for the assignment very soon.
Done.
Okay, electric potential due to a point charge. Electric potential due to a point charge. Now, go to my definition. What is my definition here? Potential at a distance, at a point represented by R is equal to what? W infinity to R by Q naught by external force, isn't it?
Yes, sir. Against the electric force.
Okay, just against the electric force. External force, this is electric force. So let us follow that thing. I've got a plus Q. This is source charge. Why am I calling it source charge, Vamshi? Why am I calling it a source charge? What is source? Source of what?
So due to that source charge,
electric field is formed in the space which we are not seeing.
Source charge.
I always, I'll ask a question. You go to a temple and say there is a God, right? Even I fold my hands, or somebody folds my hands and say something, we pray. In our Hindu system, there is one statue there. It is modeling the God, do you know? Because God is not seen by us. We say God would be like this. That's my model. And some Islam says there's no statue like that, something else they'll say. Or somebody else will say something. So they've modeled it on different ways. Here, electric field is not visible to us. We say that this plus Q is forming electric field here. That can be tested by bringing something here. That electric field is what? How much? At distance R, it is KQ by R square. And it will be like this, we agree. Which way?
Away from
Away like this. This is modeling electric field here, which we don't see with our eyes. But remember, the modeling of God is different for different people, and that's experiments are not there so much for that, because anybody can do any experiments and say they have seen God, they have not seen God. But all of them do not have the same experience. Here, the difference between science and that is this. This KQ by R square is same for everybody, and you can test it in the experiment. By taking this formula, you calculate the electric field, and experiment you do, they match. You here and somebody in Africa, somebody else there in Europe, someone else in America. For all of them, the same idea will be valid. Not that. Even on other planet where life is possible, they must be definitely dealing with charges. Even for them, it is like this. They may call it electric field. No, they may call it something else. They may call this as some other thing, some name charge, some R square is something. But they follow the law that as you go away, the effect becomes 1/4, or the effect is inversely proportional to square of the distance is valid, even on some other planet where life is possible. Or where life is not possible, also it is possible. Only thing is we don't know what's happening there, who people don't study it. So that was I was trying to make you understand. After which everything becomes simple. Otherwise, there's a KQ by R square formula, there's KQ by R. So how do we know where to use, what to use? And yeah, only substitution you can do. I'll give you Q naught, I will give you this, find out VR, that you can do. Or I'll give you Q naught and VR, you'll find out this by multiplying, and this you'll find out. So after that, what? Nothing. So at a distance, at this point, E equals KQ by R square, like this I have. Right? This R distance. So I would like to know how much is VR here. Okay. Hello.
Yes, sir.
So what do I do now? This I'll write separately once again. V at R equals integral. Tell me. F dot dr.
dr by Q naught.
F dot F electrostatic. Now F external.
Yes, sir.
Dot dr by Q naught.
Q naught.
But since F external is equal to F electric.
Negative sign.
E. But remember, if I put E, that will be only of this one, no? So that's why better I go for minus like that. I don't know whether you understood.
Yes, sir, because here the field is due to electric.
Electron. So if I write E dot dr, that won't be nice. I should put minus E dot dr, isn't it?
Yes, sir. So it will be because of electric force.
VR equals, I should write F electric here. No, this F external is equal to minus
F electric by Q naught into dr.
Do you follow this? And what is F electric by Q naught?
E.
E.
Minus E dr.
That's it.
Yes, sir.
So now look at this. This is E. dr E is what should I write now? E equals, tell me, kq by
R
r
square.
square r cap, and
Yes,
dr equals
dx I cap.
mod dr I cap, isn't it?
Yes, sir.
So V at R should be, tell me, but what are the limits? Infinity to R, isn't it? Hello, infinity to R, right? Okay, so V at R equals minus infinity to R. Tell me,
kq by r square
kq by r square
I
r
cap.
r cap dot
Yes, I cap. I
dr.
cap dot dr I r.
So minus infinity to R. What do I get? Kq by r square dr, isn't it? I dot r dot r is 1. So
Yes,
what do
sir.
I get now for VR?
Minus kq
Minus kq into minus 1 by r
from
from
infinity to
infinity to r. So what do I get?
minus gets cancelled. We get kq by r.
Kq by r. This is potential. So Vaishnavi, tell me again. Did you follow the maths part, or what? What is that you followed? What is that you did not follow? I'll tell you. If you follow, it's well and good. Okay. But if you did not follow, also that is one more opportunity. Like if you did not follow, you should think, why should I not follow? Both the ways it works. I don't know whether I ever told you. I learned physics for a very, very silly reason in the minds of people. Physics was looking actually difficult, you know. I remember my intermediate teachers. I thank them today. They made it so boring, difficult, and meaningless that I thought I should learn physics because that was challenging and difficult. So I've got motivation the reverse way. Many times you get motivation by looking at teachers who teach it in a great way. And I don't know, because it was looking and challenging, I thought I should do that. Otherwise, physics, somehow I was always unhappy with that. What, Vaishnavi? Why am I telling you this? Not to beat my own trumpet. What I was trying to tell you was, you cannot say that you don't understand something without making a trial for it, making an effort for it.
Yes.
You did your effort. After that, it doesn't somehow go with you. Then okay, I agree. Because we don't know why some people like something, why some people don't like something is not very clear. I've been telling you, you're writing an exam, you have a goal. When you entered, you thought, at least if not your parents thought, at a minimum level, I can tell you, and you agreed, probably knowingly, unknowingly, grudgingly, or accepting it, you agreed for it. And there is a syllabus, and there is a particular way of doing things. Some student does it with one attempt. Some other student will do it with second attempt. Somebody will do it third attempt. Following a lesson, I mean to say. If you really decided that, if you are emotionally very strong, but your understanding levels are less, I really don't care. If somebody masters it with one attempt, you'll master it with 10 attempts. Believe me. That's all. I've seen, I've learned it from children, I'm not telling just like that. I've seen so many students actually, somehow they have this determination, grit, and they follow somebody who is serious. Like I tell people, come on, go and read the same lesson, just practice it. Then you'll really like doing problems, and there's nothing like mugging in physics. And that gives a beautiful way of thinking. and exam also will happen that way. Sriya, do you know, you heard of this fellow? What is this? Srikara's classmate. What is that fellow's name? The 230 rank fellow, Manideep,
Manideep.
right?
Yes, sir.
So he and one more fellow were there. Both were equally good actually, and that other fellow is actually very highly motivated fellow. He went to some college nearby, and I was pleading with them, come on, why don't you come here? But they didn't, went there for a different reason. So the difference in the ranks, I'll tell you. 230 this fellow, 2400 that fellow. If at all there's a gap, that gap should be just around 100 up. I mean, he could have got 130 or 330. That's all. That was the thing when they started. He was into completely wrong way of doing things. A very good student in a wrong way. He was doing things. He's also a very good student doing things in a right way. That's the difference in terms of ranks, I'm telling you. No one can say that there's one more silly way of getting ranks. I just disprove it 121 times. And he was more motivated than this fellow. He was a little more matured. He was a little older to him. And he did all his intermediate syllabus by 10th class. You know, this fellow. But all in a bad way. Like Vaishnavi was saying, some formula, some problem, with good brains, basically, try to understand. So he believed that in a blind way, because the whole world is doing that, and ended up with this one. Riya, you can ask people, they'll tell you. So don't get into a wrong impression that exam approach is different from learning approach. In the class, learning approach should be right, and it works for all people. A slightly bad method will work for a better student because he'll know how to remove the bad from it and use the important things in it. But for ordinary fellows, a bad method will spoil them once for all. There's no hope for future also. Okay, so just come prepared. My least expectation is that when I'm speaking, you should be able to recollect the old formulas. We can discuss, we can talk, and then go for problems. Do you follow?
Yes, sir.
Okay. I'll close it for now. People are already leaving. So K cube is a formula we derived finally, right? And remember, this is also a derivation for the board exam, right? Which is done in a very bad way in the book. I've done in a very nice, proper way for both exam and application. All right, I'll close it.
Thank you, sir.
Thank you.